Hello, just want to welcome everyone as you file in. Going to allow about another minute or so before we get the presentation started, but as always, we thank you for joining us. Again, going to allow about another 30 seconds or so for everyone to get filed in, but you are in the right place for the Safety and Health Magazine webcast. Thanks for joining us. We'll begin in about another 30 seconds. Well, an official hello, everyone, and welcome to today's Safety and Health Magazine webcast, Safety in the Age of AI, How New Collision Avoidance Technology is Transforming Operations, sponsored by Matrix Design Group. My name is Kevin Drewley. I'm an associate editor with Safety and Health Magazine, and will be moderating today's session. Thanks for joining us. In a few minutes, we'll start a presentation, but first, let's review some preliminary items. The views of today's speakers and organizations are their own and may not necessarily reflect those of the National Safety Council or Safety and Health Magazine. Any mention of a commercial enterprise, product, or publication does not necessarily mean the council or magazine endorses those items. At the end of today's webcast, we'll conduct a question and answer session. To ask a question, simply click the Q&A button at the bottom of your screen, type your question, and click the send button. Feel free to ask your question at any time during the presentation. You don't have to wait for the question and answer session to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we might not get to every question. Any unanswered questions will be forwarded along to today's speakers. At the end of the webcast, you'll be asked to complete a brief evaluation survey, and we'll let you know more about that after the presentation. This webcast will be archived so you can access it after today's live event. To view this webcast and all of our past webcasts, please visit safetyandhealthmagazine.com/events. With that, let's go ahead and get started. Our speakers today are Jackson Phillips and Brian Jones. Jackson is a sales specialist with Matrix Design Group and focuses on safety innovation in the industrial sector. He specializes in OmniPro Vision AI, a pedestrian detection system powered by artificial intelligence that helps reduce workplace incidents and improves facility awareness. Brian is Vice President of Sales and Marketing at Matrix Design Group. He brings an extensive background that includes more than 15 years of experience in industrial and mining technology sales management, with emphasis in the areas of collision avoidance and proximity detection. Again, we thank you all for tuning into this presentation. Jackson, whenever you're ready, go ahead and take it away.
Thank you, Kevin. All righty. So thank you to everybody who's able to join us and participate today. Safety in the age of AI, transforming workplaces with collision avoidance technology. I'm Jackson Phillips. I've been with the company since 2023 as a key account manager focused on our OmniPro product in the industrial sector. I work closely with our B2B end users as well as customers in the dealer market. And my day to day activity requires a focus on helping industrial operations take a proactive approach to enhance workplace safety through said AI powered pedestrian detection technology. I'm joined here by Brian Jones, our VP of Marketing. He's been with the company in a full time position since 2007, where he started off as our marketing director. Brian's been in many different roles, as Kevin alluded to, throughout his time here, and has been lucky enough to see some of our products that we'll refer to today transpire from an entry level conversation basis. Brian will join us on screen once we get to the Q&A portion, but we will move on for now. So our goal today is to expand the knowledge on how AI drives change in relation to workplace safety transformation. We want to demonstrate the capabilities and uses for technology that is surprising to find out exists, and the struggles and pre-misconceptions surrounding AI, the benefit of a long-term AI solution as it relates to the OSHA standards that we'll talk through here in a minute, and what roadmap looks like for the future of AI in the industrial safety sector. We also want to make sure that we illustrate the idea behind preventing the top 10 vehicle related incidents, which include close proximity pedestrian strikes, rear end collisions, collisions with other vehicles, intersections, unattended vehicles, driver fatigue, distraction, incorrect vehicle use, failing to yield, and poor road construction or conditions. We want to highlight how the effects of AI pedestrian detection awareness helps to mitigate these top 10 examples. So before we get going and talk about our laid out action items, want to address who we are and what credibility we have that has led us to be considered a technology leader in said safety systems. Born in 2006 and launching our first project in that same time frame, Matrix set its sights on proximity detection within the underground mining market. The final product was a magnetic-based system coined IntelliZone, and then moving and traveling in time to today, IntelliZone is the top technology used in U.S. underground mines and is still being advanced to account for a long-term product development and life cycle that we anticipate will provide us with new customers into the distant future. Jump into 2018, understanding the technology and use case needs above ground, Matrix decided to diversify its product offerings and strive to develop a system for mobile surface equipment. And prior to brainstorming the solution that we'd allocate our resources towards, we would leverage that 10 plus years of technology experience and explore technology and grade them on 4 criteria. One, we didn't want to have a tag based system. You know, you can control who comes in and out of an underground mine. That's a little bit of a hard hoop to jump through when you talk about surface level industrial spaces. And in that same sense, systems that require RFID tags kind of puts a lot of trust in the workforce to wear them, charge them, or report them when broken. You know, two, we still have to be able to repeatedly detect and alert on specific objects, whether that be a person, truck, stop sign, etc. And that has to be performed with a high level of confidence. And then three, we need to be able to work in a wide variety of environments, both indoor and outdoor, or both. And then four, we have to be price competitive, no matter what the benefit is to that technology that we want to implement. If we're not in a cost effective solution, no one's going to want to implement that technology. And due to the laid out criteria, the AI based camera system presented itself as the front runner. Alrighty, so introduction to AI in the industrial workspace and how that relates to safety. So, what is AI as it pertains to this conversation and me? I'm sure that we're all familiar with the rapidly developing AI. Um, this surrounds us every day, whether that be Siri or Alexa, or even open concepts like Cloud AI and ChatGPT. While all of those things are great, and I'm no stranger to utilizing them on the daily, especially when it comes to making a presentation that's 40 minutes like this one, they're all generative and have a free flowing and self evolving nature to them. AI, as it applies to pedestrian detection, is at its core level machine learning, which is the foundation and product we have to thank for the generative AI we have around us today. With machine learning, you'll find that your system isn't going to learn from its environment and can't do anything it hasn't been taught to do. So, in layman's terms, there is some piece of intervention that has to take place in order to advance or edit that system. But on the bright side of that, an AI pedestrian detection system isn't going to be able to teach itself to do anything out of the ordinary or do anything that it's not meant to do within your facility. So we're able to take that machine learning, pair it with computer vision, and the outcome that we get is real time valuable data and alerts that can guide you along the process of potentially hazardous operators, pedestrians, and areas within your location of concern. So, looking at the importance of safety in industrial environments and how that pertains to powered industrial vehicles. With that AI, what are some of the few important factors that have helped guide us in recognizing potential areas for growth in that above ground market? Understanding that people are our number one asset inside of company success. It's shocking to know that OSHA estimates 35,000 serious injuries occur every year, with 67 of those resulting in fatalities. The result of these injuries account for 108 million lost days each year due to work related injuries, and the potential for fines in case of a fatality is on average upwards of $1.3 million. AI integration can help you negate some potential OSHA fines that can be upwards of 1655 and double each day thereafter beyond the date of abatement. Looking into some of our customers that we'll reference later on who happen to be safety leaders inside of their respective industries, we found that engaging with the foot traffic workers led us to an understanding that a proactive or preventative approach to safety displayed in the correct transparency creates a sense of camaraderie. And while there are plenty of other factors that come into play, that's the one that we're going to hit on throughout the majority of this presentation. If you want to take a deeper dive into a few of those other factors, feel free to connect with us after this presentation's over. So, tying into that, it's important to note that the majority of workplace safety incidents, they are preventable. And history has shown that most approaches taken to safety have been reactive rather than preventative. And the introduction of real-time data provided by AI is it's enabling users to optimize predictive measures and base preventative actions in a proactive manner. So, collision avoidance technology for forklifts. I want to note that while we're going to focus largely on forklifts for the remainder of this presentation, please be aware that the application has its use case in the standalone capability as well as for other PIVs. So, the main goal is to enhance your operator and pedestrians' awareness of what's happening around them. And the steps taken to provide that effect include one, the use of advanced sensors and cameras that provide real time detection of obstacles inside the forklift's path. Two, taking those detections and providing an output of audible and or visual signals to alert the operator and pedestrians. And then three, these systems also add a feel aspect to the alerting in the case that throttle integration is available, making the operator aware that they need to either turn or hit the brakes. So, how does AI enhance forklift safety? And while there are many benefits to the operator, there are also some of those secondary benefits that come from real-time alerting to take a preventative approach within your facility. Capturing images and alerts in a logging format allows managers to address those potentially hazardous practices being used by operators and pedestrians. And then in some cases, predictive analytics and hazard mitigation can be utilized to address the most hazardous areas or pain points within a facility where the manager can take the necessary steps to drive down pedestrian to PIV interactions. So, some of the ever evolving features that exist within the technology included on the market today. You're going to get the direction of travel alerting. This is one of the first steps taken by the creator of many of these technologies to drive down what we consider nuisance alerts. You're only going to want to be alerting on what's in front of you when you're traveling forward, and then vice versa. This also ties into the motion factor as well. If the parking brake is on and no one's in the seat of that PIV, there's no actual benefit to those alerts. Two, throttle integration allows the system to take action on real time detection and disrupt the throttle signal to the machine, allowing the operator more time to make a decision. And then lastly, using key switch power means systems cannot be turned off. and will always be operable when that forklift is running, using a password protected dashboard and allowing the manager to monitor who has access to the forklift system negates the possibility of the operator turning the system off or adjusting its alerting features. That's just a step in making sure that we're ensuring full functionality of the system. So, taking a look at what implementation looks like into industrial locations, we have a few case studies that we want to share of those industries that we're in currently. I'll pause for a second for this poll question. I think I've been breezing through those. Alrighty. So when we look at implementation, we define success at a high level based on really four broad pieces of criteria. One being sufficient knowledge and transparency that encompasses everyone inside of a facility, having an up to date awareness on the implementations and uses behind it. Two, positive feedback regarding change in operator and pedestrian reaction to the technology. Three, tying back to the human intervention portion of machine learning, customer feedback of challenges faced to ensure we are optimizing the system for the environment and use case that it's being utilized in. And then four, image data showing real time alerts, which is what we consider our proof of concept. So three cases where success has taken place derives from three customers of ours currently tackling large scale corporate level rollouts in the pulp and paper, building and construction, and then iron and steel industries. And then some of the feedback we've received from these customers who are considered safety leaders in their industries can be summarized as, change in operator activity. We've seen our customer in the building and construction industry report the change in operator activity and paths taken to avoid pedestrian interaction. Two, three fatal incidents have actually been prevented. We've been presented video and image data from our customer in the pulp and paper industry showing three incidents that would have resulted in the least an injury. And those three incidents have taken place just since December of 2024. And then number three, operator buy in. Operators, rather than relying on the system's functionality, have started policing foot traffic around them to avoid pedestrian interaction and slow productivity. And then while we highlighted a lot of the benefits surrounding our current customer personnel, naturally there are some challenges that come into effect with any sort of change, but how are we working to mitigate those? So, one, you're going to see resistance to change. In all situations, people are biased to what they're used to. And in addition to another system being added on a PIV is no exception to that at all. To mitigate this, we take steps in meeting with our customer on average of 4 to 5 times prior to implementation with the buyer, the operators, the managers, and then all of them together so that we're optimizing transparency on implementation and goal and result. And then two, cost considerations. Cost for AI technology can weigh significantly on customers' budget. And while there's no way around the cost associated with this technology, it's important to reference the statistics provided by OSHA on what the costs associated with an injury or fatality comprise of. And while insurance premiums, they're not going to go down socially based on the installation of an AI pedestrian detection system, that could be a future secondary benefit or effect of having less accidents within your facility as a whole. And then looking at number three, you have the training and support challenge. Implementation without support is meaningless, and providing ongoing support and 24/7 access to an internal customer success team at no cost for conversation or over the phone support That's a step that's been taken to guarantee long term success without the necessity of a third party intervention. So, how does AI technology integrate into current systems and processes that facilities might already have in place? Step one is understanding that AI systems aren't here to replace current safety processes and standards, but rather supplement them in reaching the desired effect. So, ensuring success of training programs to utilize employee buy in is pertinent in adhering to current standards, utilizing the system to its full capacity, whether that's pulling images and data or addressing the information that you've pulled. That helps ensure that it's not working against what you already have. And this is something that we see arise often with contacts or customers who already have built-in telematic systems. AI isn't in place to replace the countless benefits that a telematic system offers, but rather add in addition to the data captured by a telematics system itself. So, addressing all of these concerns and disadvantages and advantages, what has Matrix done in the steps that we've taken to tie all of these together? Um, Matrix has brought to market its own AI based detection system coined OmniPro that works to alert operators on obstacles through three senses: see, hear, and feel, with a audible, visual, and throttle integration alerting aspect. And that alerting is based on a password protected alert and warning zones that are configurable based on whatever the contact has preferences for. And the system does not utilize any wearable devices or tags as a standalone system. So, what OmniPro has done is it has met all four criteria that we referred to in the historical part of Matrix at the beginning of the presentation. So currently, OmniPro is trained and being utilized in the field to detect on people, material handling equipment, and other objects like stop signs within the path of travel. With any system like this, I like to tell people that it can be trained to detect on whatever obstacle a customer may want, but that's going to come at a what kind of cost case scenario. If the system is trained to recognize poles and racks within a facility, then it's just going to go off all the time and either become background noise to the operator or a nuisance. So, in prioritizing objects like people and other PIVs, we can optimize the effects of the alerts we are outputting to the operator. And we'll talk in a few slides how we're gearing in the future to supplement OmniPro to protect collisions on items we don't want the camera to detect on. And then in looking at our typical system components, we will give a brief explanation of each item that you're going to see here on the screen. Number one being the Omni Pro Hub, capable of handling up to 5 cameras. This can be characterized as the brains of the operation. Utilizing what the camera sees, the hub calculates the direct output or alert to address the operator with. Our hubs come with built-in Wi-Fi, meaning there's no need to integrate into your facility's IT infrastructure to access images, but rather but you can rather pull images and data directly from each hub by connecting to it wirelessly with a smartphone or laptop that you have. And then looking at number two, our camera or the eyes of the system itself, carrying an ability of 120-degree point of view, which is actually the same as a human's binocular point of view. We're able to see obstacles in the vehicle's path of travel, which then allows the hub to push out alerts, understanding there are applications that may require a larger point of view. Additional cameras can be put in place to capture that desired range. We'll skip item three. That's just our cabling and move into item four, which is our universal mounting bracket for the cameras. That's dependent on 350-pound industrial magnets, which are utilized considering OSHA does not allow you to tap, weld, or drill into a forklift mast. Moving on to item 5, this is our simple indicator, which carries 2 out of the 3 alerts that we put out, which come in the form of a visual light matching the zone that is breached, as well as a 95 decibel audible that can be minimized by a baffle on top. Skipping to item 7, that's what we consider our throttle module. In the case of a red zone breach or alert where the customer wants the throttle interrupted, we can disrupt that throttle in a sense of percentages. The easiest way to put that module into perspective is explaining in a perfect world case scenario and for ease of math. There are machines governed at 10 miles per hour. And if the customer states they want 90% of that taken away, the throttle disruption will only allow the machine to go 1 mile per hour at full throttle. But it's important to understand that with this throttle module kicking in, we're not triggering any braking on the vehicle. Reason being is we want to be minimally intrusive on the system or the vehicle that we're putting our system on. And we don't want to jerk the operator in the driver's seat. We don't want to shift, tilt, or drop a load. And to that same effect, there are key differences to how this function works on an IC versus EV vehicle. In the case of an IC vehicle, the unit is naturally going to coast for a while, simply giving the operator more time to make a decision, whether that be turn or brake. And when installed on an EV lift, which have that new beautiful aspect of regen braking, just like a majority of EV cars do on the market today, as soon as that throttle is pulled away, regen braking is going to kick in and start chalking that machine down at a quicker pace. Skipping items 8 and 9, eight's more for our underground application, and 9 is just the simple hub mounting for the forklift cab. Item 10, that is a simple display. This isn't a requirement for the functionality of the system. There's no true dashboard accessible through the component itself. In the past, we had a large majority of customers adamantly defend the idea that they didn't want operators looking at a screen while driving. We've kind of seen a shift in that tide, and a large amount of our customers live by the testament that everybody has a backup camera in their car now that they're comfortable with. Why wouldn't we give our operators in the facility the exact same kind of feel? And that is something that is completely up to the customer themselves. So transitioning to our theory of operation, not a great illustration of what our operation captures from an actual zone standpoint. This image does highlight the fact that our typical configuration comprises of a yellow warning zone as well as a red alert zone. Although alerting in each zone is dependent on customer wants and needs, standard alerting points to yellow zone breaching would trigger the visual indicator light to turn yellow, and a red zone breach would then turn the light red, trigger the audible, and interact with the throttle as well. You also gather a good idea of where all the components are mounted on the lift. Looking at a true example of a warning zone breach on this slide, you'll notice that we're ignoring the obstacles off to the right, which are a couple carts and a pallet jack, and letting the operator know with the indicator light in the cab that there is a person inside of their warning zone. You'll also see that that person is scored with a 71% by them. And the best way that we explain that confidence score is we don't want to be alerting on anything that the camera is under 60% confident is not a obstacle. Reason for that being is inside of a facility, if a pedestrian decides to hang up their PPE gear on a hook on the wall prior to leaving the facility, if that's a hard hat and a PPE suit or reflective suit, at first glance as a person out of my peripheral vision, I might be 30% confident that that's a person until I get a better look at it. The camera's going to be the same way. We don't want to alert on those kind of things. That's one of the steps taken in driving down those nuisance alerts. So we're capturing true obstacles. Here we see an example of an alert zone breach in the reverse data travel, with alerting as follows. One, you're going to get the red indicator light. Two, you'll get the 95 decibel audible alarm. And then three, you'll get the throttle integration disruption. Um, this is also an opportunity to understand that, unlike the slide before, where we saw a forklift traveling in its respective area and some were standing probably where they were allowed to be, this capture could be characterized as unsafe behavior inside the facility, and the image data available would allow for intervention under management discretion to be displayed as a learning opportunity. I also know that we're alerting on him even though the camera is only 46% confident. This is just an old image capture prior to firmware being advanced. In this slide, we see our system zone configuration, which is password protected and available to the customer, whoever that might be within the facility, whether that's the point of contact or the highest manager over the fleet. That is completely up to you. But zones are machine specific and can be changed as many times as you want to achieve the desired results. We understand that larger pieces of machinery require bigger zones, and vice versa. Smaller pieces of machinery might require smaller zones, as well as the differences in the environments that those pieces of machinery might see inside your facility could change how you want to set those zones up. And since we're capturing images and not live video feed of incidents, we want to take a moment to give you a chance to see what an example of those frame sequences actually look like when they're downloaded. You'll see that the camera detects the person in the work bay, although they blend in with that environment around them. That with that being blue shirt and blue trash bag liners. Um, right here, we're showing you the zone breaches, but what you'll have access to can be looked at images that are pre-event, so right before the zones are breached, event, so during the zone breaches themselves, and then post-event, right after the zones are breached. So that way you get an idea of what behavior took place in order to trigger those zones. So, product aside, what steps have been taken to address the struggles surrounding successful implementation into an industrial workplace? The first step in that is ensuring that knowledge transfer between provider and end user is something that never stops. From the initial product demonstration to the time following completion of installation, end users have access to a 24/7 internal call line to address support needs. Firmware updates, those are not going to be tied to any recurring costs, and um, they're shared with the customer upon release. And the most key aspect to implementation is dependent on the depth of knowledge shared with key stakeholders in the facility. Installations are requested to involve on-site mechanics or dealers that can be educated on the technician portion of the installation. Project leaders are trained on how to use the system dashboard in order to configure zones, update systems, and pull data from the hub. And operators are given training on how the system will react and what they should expect. Each of these items are going to be connected to marketing and training material, which includes user manuals, installation guides, an operator experience video, which I'll show you here on the next slide, and then coming soon, an in-depth installation video itself. So for this next slide, I'm going to go on mute and we'll watch a brief video.
Welcome to the OmniPro Operator Experience video. Today, we'll guide you through the key features and best practices for operating the OmniPro Vision AI collision avoidance system on your mobile equipment. OmniPro is designed to enhance safety in your facility. It visually monitors areas that may be blocked from your view by the mast or your load and alerts you to the presence of people or selected objects if they get too close. Let's take a closer look at the key components and how they interact. The standard components of the OmniPro Vision AI system are the cameras, hub, and the audible and visual alerting devices. The hub provides power, data communication, and houses Matrix's visual artificial intelligence processing software that can provide seamless machine integration options. The camera's powerful high-speed processing takes place at the edge, on device, leveraging Matrix's award-winning technology. Its customizable zone programming helps minimize false positives and nuisance alerts. The hub acts as a storage unit for captured, time-stamped images which can later be retrieved and analyzed for additional safety insights. OmniPro's Vision AI cameras are typically mounted facing the front and rear of the vehicle to monitor the vehicle's path of travel. It will automatically monitor your path of travel. These rugged, compact IP67 rated cameras are equipped with specialized sensors that enhance its performance. The cameras gather real-time visual data and send it to the hub where it is interpreted and, when necessary, acted upon. The audible and visual indicator devices alert the operator of a zone breach. There is one indicator device per camera, so if you turn your head to back the vehicle, an alert device will be in your line of sight. In most installations, OmniPro creates two alert zones, a yellow caution zone and a red alert zone. The zones are customized based on your facility's requirements. After the OmniPro system powers up on your forklift, make sure the cameras are not blocked or have an obstructed view. Remove or secure anything that impairs the camera's field of view. Let's take a look at a situation where a pedestrian breaches a customized yellow alert zone. OmniPro camera captures everything in its field of view and sends this information to the hub. When a person enters a yellow caution zone, they're getting dangerously close to the forklift. The hub identifies the zone breach and triggers a yellow alert light. This tells you to slow down and visually identify the location of the pedestrian, then take appropriate action. Red zone alerts are the most serious because this means a person is in imminent danger of being hit by the forklift. When someone enters the red alert zone, it triggers a red light, an audible alert. This alert tells you to immediately stop until you can visually identify the location of the pedestrian. When they are clear of the red zone, the audible alert will stop. As a forklift operator, your responsibilities include the proper use of the OmniPro Vision AI collision avoidance system, adhering to your facility's safety protocols and reporting any issues or incidents. To ensure safer forklift operation, always perform regular system checks, position cameras correctly, maintain clear communication with your team, and never assume someone sees you. These practices and a properly working OmniPro system will help you avoid accidents. 1. Keep up to date on safety training. 2. Inspect your forklift before starting your shift to make sure all safety equipment is working properly, including your OmniPro system. 3. Learn how to avoid, when possible, driving in areas that have a high concentration of workers. 4. Don't speed while operating a piece of mobile equipment. 5. React immediately to all OmniPro Zone breach alerts. 6. Share your ideas on how to create a safer work environment. 7. If you encounter any issues with OmniPro, report it to your maintenance team immediately. Thank you for watching the OmniPro Operator Experience video. You and OmniPro are helping create a safer and more efficient workplace.
Alrighty, thank you for taking the time to watch that with us. So, looking into the near and distant future, in the world of AI pedestrian detection, which has endless growth avenues through OEM and system integration, machine alerting can become streamlined and more effective. Sensor fusion with technologies like radar and impact detection can offer alerting capabilities on all objects to minimize facility and vehicle damage while still prioritizing human to PIV interaction through cameras at a longer distance. And tying all of this together under one data automation umbrella or cloud would allow for a premium technology in the future. To summarize, AI and collision avoidance have revolutionized the way workplace safety is perceived and achieved by putting the safety of people at the forefront of the movement without impeding on productivity capabilities. A new set of safety standards has begun to cultivate itself with AI driving the force. I think I'll turn this back over to Kevin for the Q&A portion of this section, but just wanted to say thank you to everyone for taking the time to join us today.
Well, excellent. No, we thank you. Great job, Jackson. Thanks for sharing your insights and your expertise. Before we do start the Q&A, just want to let everyone know about the evaluation survey we're asking you to complete. That survey will open in a different screen after this webinar. And as always, your input is very important to us as it helps us improve our future webcasts. Again, if you'd like to ask a question today, just click that Q&A button at the bottom of your screen, type your question, and click the send button to submit. If we don't get to your question today, all unanswered questions will be forwarded along to our speakers. And with that, let's get to some questions. To start, this backtracks, I think it was close to about 2/3 of the way through, but it just was backtracking. It says, is it OSHA that doesn't allow tapping to the mast, or is that the manufacturer?
I'll kick that one to you.
Joining. Hi, my name is Brian Jones. Typically, that's the manufacturer. They don't enjoy tampering with machines too much, and the end users don't want us messing with those masts either. There's structural integrity issues with tapping into the mast, so we typically use magnets to mount the components. Haven't had any issues with regular operation of those systems so far.
All righty, thank you. Next one asks, how does the system handle complex environments with high foot traffic or low visibility?
It's a high foot traffic is an interesting issue. Typically, we would see zone breaches with any pedestrian out in front of the machine. If you're going to be, typically you would try to keep your machine away from those types of areas during high traffic times. But inherently with the technology, it's going to alert if a machine comes within a certain distance from a pedestrian. Low visibility. We do have a low light sensor on the camera itself. So think about nighttime operations or evening operations. We do have some capabilities to do things there that you may not think that a camera could do initially.
All righty. Next one asks, how secure is the AI data and recommendation?
Ask that one more time.
They're wondering, how secure is the AI data and recommendation?
So our policy is that the data belongs to the customer. We have a secure database that the data is recorded into. We don't require cloud access, so the data can be stored on-prem or on the actual hub itself. So it can be as secure as you want it to be. If you do want cloud access to be able to see your data, that does go out to a different environment, but it's got standard security protocols around that data. And again, our policy is that the customer owns that data.
And to piggyback on that, one thing that we do offer surrounding employee recognition and safety, you do have the opportunity when those images are pulled for those to be blurred images. So we're not broadcasting any specifics surrounding the employees or pedestrians within the facility itself.
All right, thank you. Next question asks, what kind of training is required for teams to effectively use AI pedestrian detection systems?
Yeah, so that one truly comes down to the transparency in the implementation. Like we noted, we want the customer to be in as involved as possible throughout the entire process. This isn't something that we want to box up real nice and pretty, leave on your doorstep and say, here you go, you guys take care of it. We want to make the point of contact completely aware of everything that's going to be going on in the ins and outs of the machine and what the operators and pedestrians themselves can expect. During the time that we are actually doing that installation itself, what we're able to do is work hand in hand with the mechanics or the dealers that you guys have on site on a regular basis to make them aware of the technician piece of that installation. And then we also want to make sure that before we leave, there is someone on site who has been fully trained and has the autonomy over the dashboard, whether he chooses to share that login and password with other people in the facility is completely up to him. But what they're able to do with that is we'll train them on how to go in, pull those images and data so that they can be used from a management standpoint. And post those installations taking place, we want to make sure that we are either training the trainer at a high but in depth level, or we are speaking with all the operators within the facility while making them aware of what they can expect from the technology itself.
Ready? Next question asks, is this technology available for vehicles such as service trucks?
It can be. We've outfitted the system on a wide variety of vehicles to date. It depends on the type of truck and the speed that they're regulated to. There's a number of uh, aspects of how they want the system to perform that we'd be interested in testing on different types of vehicles. But uh, typical flatbed service truck, you could outfit it on that. Again, it depends on what you want to try to do with the system. So there's no, I don't want to say there's no limitations to the system because I'll probably get in trouble for that, but it can go on a wide variety of different types of vehicles. We would want to discuss the use cases for exactly what you want to achieve there.
Alrighty. We still, folks, have a couple questions queued up for Jackson and Brian, but just again, a reminder, if you'd like to ask something of them today, click the Q&A button on the bottom of your screen, type your question, and click the send button. Moving on, what is the range or average cost of this system per truck?
It's highly dependent on the system itself. So if you're having a single, dual, 3, 4 camera system, those prices can vary. Um, it's going to be less than 10 grand, call it that. And then you're going to have additional install costs based on how many trucks you're installing at one point in time. Uh, there's just associated costs with that, but um, it's price competitive in the market. We'll leave it at that.
Alrighty, thanks. Next one asks, how do cameras respond to changes in light conditions, such as going from inside the warehouse to direct sunlight or vice versa? And with that, are there any blind moments?
So, we like to compare the camera to what an eyeball is capable of as well. Like Brian mentioned, we do have, light reduction capabilities in the case of going from bright to dark. But going from your standard indoor lighting to outdoor, where the camera might be facing the sun, what you're going to find is, for a very minimal time, which is just a few seconds, that camera is going to take a second to adjust to the lighting, just like an eyeball would. But what you're going to see is that it's going to adjust quicker than what the standard human would be capable of.
How does your camera accommodate high and wide loads carried by fork trucks?
I can go. Um, you know, Not to tell anybody what they should or shouldn't be doing, but the camera can't detect on what it can't see. And the normal practice or standard is that if the operator can't see because the load is lifted up high enough, that their view is obstructed, the camera is not going to be able to see as well. In a lot of facilities, that is the standard for that is they should be going in reverse. I know that you can't get around that in cases of loading docks going in and out of trucks. But the testament to that is the camera can't detect on what it can't see.
Next one asks, does the system comply with European data privacy regulations?
We'll have to get back to you on that one. Uh, I would lean toward yes, but I would need to confirm that.
Sounds good. No, as we've said, all the information and folks' contacts will be forwarded on to you.
We're happy to reach out afterward.
Okay. Thanks. No, and with that, you all still have access to these two. So again, if you want to ask a question, there's still a couple remaining, but still have some time if you want to float some questions to Jackson and Brian. This question asks, it just says basic. Does AI have access to the OSHA regs?
Our AI does not. So our AI is trained specifically on detecting people in a environment near a machine. There's a lot of different types of AI. There may be one in the ether that is trained to scrape OSHA's websites and regs, but ours is trained to do something a little bit different. I think.
For the moment, we've exhausted questions, and not to tap dance. And I know you guys have certainly covered a lot of ground, but what, if anything's been left unsaid from today's presentation? Again, I know you've covered lots of ground.
From an informational standpoint, I think that we covered a lot of ground there. Our contact information is still up on the screen. If we're looking for a more in-depth description on what our technology capabilities are, feel free to reach out to us. We can get a more formal presentation together. But as far as information presented today, I think that we've covered the majority of it.
Anything further, Brian?
Nothing for me. We encourage people to reach out. If you've got questions, we're always open to having conversations with you and discussing new applications for the system. Like I said, you can see a lot of the applications on the website that we've tried previously or have outfitted already. But we're always open to new ideas and having conversations about different applications. We learn something new every week about an application to the systems that they believe a problem that it can solve. So if you have any interest, if you want to reach out, we're available anytime. Happy to have a discussion with you and bring you along on your journey to implementing these systems.
All righty. Well, no, I thought there might have been one more question, but it's someone providing some nice feedback saying thank you for everything. But just wanted to put out, if you guys don't mind, one more call for questions.
Sure.
All right, I guess we're going once, going twice. Again, I know you've covered a lot of ground. We appreciate it. We just well, no, with that, no, again, thank you both. You certainly lent a lot of expertise today. As you all can see, Jackson and Brian have their contact information on the screen. So as they've indicated, feel free to reach out to them with anything further. And once again, we hope you all take the time to fill out that forthcoming evaluation survey and give us your feedback on today's webinar. Actually, someone is asking what's the cost of the system, or could you review kind of some cost particulars real briefly before we wrap up?
I can go. So looking at the true cost of the system, from an installation and labor standpoint, that's going to be completely dependent on the location that you're in. But when we previewed our typical dual camera kit there on the system component slide, which is going to allow you forward and reverse visibility, all in, throttle integration included, labor and travel included. You're going to be in that average of 10.5 per machine. Naturally, you have the opportunity for us to have discount conversations depending on the scale of the project. But for an intro level conversation, 10.5, I think, is where we're comfortable review presenting to the public.
Okay. Sounds good. Well, no, barring another question in the next moment, with that, we will end today's Safety and Health Magazine webcast. And once more, we'd like to thank Jackson Phillips, Brian Jones, everyone at Matrix Design Group, and all of you who listened in. Thanks and have a great day.